Hi guys, let me take you through the solution for question 12.5. So this question is about the mean calcium intake for women aged 18 to 24. So the null hypothesis value here is that the mean calcium intake is equal to the recommended daily allowance of 1200 milligrams per day. The concern is that women aren't getting enough calcium, so the mean calcium intake being less than 1200 milligrams per day, that is the alternative hypothesis. So in terms of the conditions, this is not a random sample, so you should state that. The truth is we have to assume that this is a random sample in order to write our conclusion at the end. Of course, what that means is that we need to take our conclusion with a grain of salt. So for independence, there are 38 observations, so 10 times 38, that's 380. That's certainly less than or equal to the number of 18 to 24-year-old women. Of course, I'm not convinced that that really applies because these are volunteers. Volunteers could certainly be from, let's say, the same gym or use the same supplements because they're friends and they talk about it. It's really hard to tell. So in terms of normality, the sample size is 38. Well, that's greater than 30. So we're at least in a situation where the central limit theorem applies and we can act as if our sample means are distributed approximately normally, but that approximation is really important. So looking at then the sample data, I have entered the sample data into list 1 on my calculator. So running one variable statistics, we get a mean of 926 milligrams per day and a standard deviation of 427 milligrams per day. That's an awful lot, but that lets us calculate our t-score, or our standardized score. Our observed sample mean is the 926. The actual mean of the distribution is, under our assumption that the null hypothesis is true, is 1200. So under the assumption that people are getting the correct recommended daily allowance, the standard deviation from our sample is 427, and the sample size is 38. Very good. So you can calculate then our standardized score, or in this case, it's a t-score. It's a t-score because we don't know the population standard deviation. We have to use the standard deviation of the sample in its place. That's an important idea. So this t-score is approximately negative 3.96. So let's talk about what that t-score actually represents. What we're saying is, if the null hypothesis is true, so if the mean is really 1200, notice we used the 1200 in the calculation, so if the truth is that women are getting 1200 milligrams of calcium per day on average, how likely is it for us to take a sample of size 38 and get a mean that's as extreme or more extreme than 926? Well, in order for us to calculate that, we should look at the distribution. So this is a t-score. It is still a standardized score, so its mean is 0. Its standard deviation will still be 1. And notice how extreme our t-score is. It's negative 3.96. So literally our sample value, our sample mean is so extreme that it's almost 4 standard deviations below the mean. Of course, the mean is what we assumed. We assume the mean is 1200. That's the null hypothesis value. These are t-scores, so we can use the tcdf command, second variables, tcdf. We can use the tcdf command. I'll use a lower boundary of negative 10. You can go lower than that, say negative 100. Doesn't make much of a difference in this case. So the upper boundary is negative 3.96. Be careful here, the degrees of freedom are 37. So this gives us a probability. Don't be fooled by this negative 4. The probability is not 1.6. It's 1.6 times 10 to the negative 4th. That's scientific notation. So a couple of ways that you can write it. This is 1.6 times 10 to the negative 4th, although I prefer to write it this way. It is 0.00016. That's our p-value. Yesterday we were doing an example where we were trying to decide if a p-value of 10% is a likely p-value or an unlikely p-value. Well, no matter what you think about that circumstance, I would hope that you realize that this is a very small probability. This one is unlikely. So remember, when we're writing our conclusion then, when p is low, that's the circumstance where you reject the null hypothesis. When p is low, that's when you reject HO. And that's the circumstance that we are in right now. So when you write your conclusion, you need to compare this value to the level of significance. You need to state whether or not you're rejecting the null hypothesis. And then in context, you have to state what that means in terms of the alternative. So I'll see if I can write it in this space here. So these were your hints. I wasn't expecting you to do this as a worksheet, but I'm at least writing on it because I want you to see that I was really trying to guide you with these hints. So with a p-value, and you can just abbreviate it as p, with a p-value of approximately 0.00016, and that's certainly less than our level of significance. That's certainly less than 5%. You need that comparison. When p is low, we can reject HO. So we can reject HO. So you can write HO. You could also just write in words the null hypothesis. So there's two of the three components. Our p-value, we've compared it to our level of significance. We can reject the null hypothesis. So if we've rejected that, then that suggests we have evidence, not proof. We have evidence that maybe the alternative is true. And you should write with the word evidence. We have evidence. That the mean calcium intake for women aged 18 to 24 is less than 1,200 milligrams per day. So 4 components. Step 1, describe your parameter and list your hypotheses. Step 2, write about all 3 conditions: randomness, independence, and normality. Step 3, you need to calculate a t-score. You need to give your p-value. It's also good to list your degrees of freedom. We will talk about that in a little bit. The degrees of freedom here are 37. So, and then in context, write your conclusion. Compare the p-value to your level of significance. State whether or not you can reject the null hypothesis. And state then, as a result, whether or not you have evidence of the alternative.